Okay, we've got a couple of problems. We got, okay, f of x equals x squared plus 4x, and g of x equals 2 to the x. Okay, so first of all, by definition, the function f circle g is the function you get if you replace x with g of x in the function f. Okay, so this is the definition of f circle g. When you see f circle g, you can just think, okay, f of g of x, right? Okay, now f of g of x, well, replace x in definition of f of x with g of x. Why would we do that? Well, because g of x here is where x was here, right? You go back to the definition of x and replace x with g of x. So this equals then g of x squared, because you got to replace this x with g of x, and this x is squared. So g of x has to be squared. I'm going to underline the g of x. Then I'll underline the x's just to indicate the correspondence. Okay. And then that's plus, well, this is 4x, but we're replacing x with g of x because x has been replaced with g of x. So this x gets replaced, and now we have 4 g of x. Okay. Make sense? Imitate this. You know, take good notes, write down my instructions here and follow them until it makes perfect sense. And if you get into a complicated situation, even though you know what it is, even though you do a lot of them right, they can trick you. Okay, you can look at it wrong unless you're very methodical. Okay, so we want to be very methodical about this. So it's going to be very important in a calculus course. Okay. And the reason is, in the calculus course, we build up functions from the toolkit functions that you've already seen. And almost all of calculus involves those functions, plus a few trigonometric functions that you learn about in pre-calculus too. And when you build those functions, you've got to find their rates of change, which means you got to take their derivatives. So right now we're talking about composite functions. We're talking about rates of change. Okay, these are all things that underlie really important aspects of calculus. So I don't want to say too much more because you haven't seen it. You know, you don't really know what I'm talking about. I'm just telling you, you really got to know this. Okay. Aha, did you see an aha moment there? That's good. That's good. Okay, so and I've been underlying my g of x, so I will. But now, replace g of x with its formula. And since you're saying that, well, we're asked find h of x equals f circle g of x, right? So now we're going to call this h of x. Problem stated h of x equals f circle g of x. I probably should have written the h of x up here, but we can do it that way. Okay, we said that h of x is f circle g of x, and this is f circle g of x. And now we'll replace g of x with its formula, which is 2 to the x. So we've got 2 to the x squared. Oh, I see where you got that 2 to the exponent too. So that's 4 times 2 to the x. Okay. Now we can simplify by the rules of exponents. 2 to the x to the second is 2 to the 2 times x. And this is one reason why you really have to understand the laws of exponents. Okay. That's something that people tend to confuse. Okay, even though everybody's done the assignment for rules of exponents, you got to keep reminding yourself what rule you're using when you do a power over power. Okay, because then it becomes more natural. So basic idea is don't write down what it looks like it ought to be. Think, what's the rule? Okay, because you do it visually. I mean, you can say, I think it looks like this. Now, what's the rule? Is that right? The rule is the test, not what it looks like. Okay. Make sense? Okay. Now, the second problem, and I'll give you a minute. You got everything written down that you want to write down? Because you do want to write down the details here so you can follow them. Okay. The other quick problem was next one, 5. Yeah. Okay, so again, I recommend you write this down in 3 steps, 4 steps. Okay, the 4th step will you substitute. And I guess I should have written h of x here. Okay, so then now for g of x, you don't even look at the formula for g of x. You replace x by the expression g of x, which gives you 1 over g of x. That's our second expression, g of x. Okay, and I'll even put quotes around that, so you don't think I replace it with 2 to the x. Okay, replace it with the expression g of x. Now that's a step you can eventually skip. I don't recommend you do that in pre-calculus because you're going to need this in calculus. You want to keep reinforcing what you're doing because you're going to forget. If you keep reinforcing it, it'll come right back to you when you need it and you don't stumble over it when you're trying to learn something else. Okay. So anyhow, that's good. So that I want to make sure that, yeah, I'm on this. Okay. So I got h of x equals and h of x equals, which I thought I should have done up here because that's what you said. Okay. Anyhow, then h of x equals 1 over x minus 5. Now this is where we replace g of x with its formula. Okay. And I could even write, it wouldn't hurt to write it all. I could write h of x equals f of g of x equals 1 over x minus 5. Okay, domain. Such that x minus 5 is not equal to 0, right? The equation x minus 5 equals 0 has solution x equals. Okay, so solving the equation x minus 5 equals 0, we get x equals 5. That can't be because we can't have 0 in the denominator. And the domain is set negative infinity 5 union is set 5 infinity. Okay. Okay, well, that's the process. Sometimes it's more complicated, sometimes it's less complicated. But it's really pretty much all there is to it. Just kind of gave you the rules. Okay, you know what congruent means? It means has exactly same shape and the same size. It means this one would fit right over that one and you couldn't tell that you had two of them on top of each other, okay? So this graph is congruent. And a lot of words here. Congruent to this graph, that every point of f of x has been shifted k units vertically. Okay? And I'll take a little note for students in my class, which everybody here today happens to be, but not everybody in the distance students, but I'm just going to say So the red dot is shifted k units vertically, and I won't say much about that except to just invoke the picture of what we're doing in pre-calculus, okay? And of course, that means your whole rectangle in which you're graphing this, the whole window in which you graph your function is shifted vertically, okay? And what's that look like? Well, if your function is in a vertical window, and this isn't going to be one of our toolkit functions, but let's say your function looks like this, okay? So here's graph of f of x, okay? Then the graph of h of x equals f of x plus k is directly above or directly below some distance. It has this says add up all the extra parts. As best I can make the shapes the same. Okay. So this would be h of x equals f of x plus k for positive k. Okay. The whole window. And if you get the window, if the window is infinite, maybe it's got a couple of handles here. That's way too much. I'm not going to lift it up. Okay. That's for positive k, because k is positive, then k units vertically is upward. Okay. And if k is negative, it's going to be down here. Okay. It's going to be this or this. Depending on the sign of k. It's a positive sign or negative sign. That makes sense? Okay, well, it's kind of an easy rule. Now, in pre-calculus, we talked about the red dot. I just gave you the coordinates of the red dot. Okay. And ask you in the dimensions of the square and ask you to construct the shape. Okay. But this is kind of what's going on if you think about it in the plane. So if the red dot is at the origin originally, which is typically what we use, okay, for a toolkit function, then you can see if this is a point in the middle of the low edge of your window, at that point gets up this far just along with everything else. That's real obvious. And in that case, you could say that, okay, then this would be my y-axis and this would be my x-axis. Okay. And the same y-axis applies all these graphs. So the origin is still here, but your shifted function is now either up here or down here. Okay. Well, that's not a particularly difficult rule to follow. And there's a good reason for it. Just if you've got y equals f of x, then you change that to y equals f of x plus k. That means you've added k to every y value. So it's worth thinking about. Okay, now there's another rule. Excuse me one second, I've got this. This allows me to see the screen better than I can see it over there, so I know when I'm off screen, which I am a little bit. So let's move this way. And I think we're good. Okay. So the only disadvantage of this is when I look down, it looks like I'm going to sleep. Okay. And you know, I got a great sense of balance. I can sleep with my naturally. Sense of balance goes eventually. Still pretty good for my age. Okay. Now, similarly, that thing is an abbreviation graph of alphabets. I'm going to call this G of X because I don't want two H's. Okay. I've got an H here already. You might confuse that with the name of the function. Shift in H equals H units. Shift in, sorry, negative H units. Horizontal. So if my graph of f of x is here, let's say that's my graph of f of x, okay? Because you're perfectly familiar with the idea that the graph could escape any window, the window you happen to use, in other words, up through the top or the bottom, right? So, and let's just say that in this case, the red dot is in the middle. Okay. And that would correspond to the origin. So I'm going to go ahead and say, okay, here's my, well, that there. Just totally missed that point. If my hand was blocking it, I would never miss it otherwise. Okay, here's your x-axis, right? So this means this thing, graph of f of x, could shift over here to the right. The red dot would maybe be the middle of your rectangle. Just think the red dot is the middle of your rectangle. Window that you're looking at. And it shifts over here. Like so. This would be f of x minus h. H is positive. Okay. So if you shift the graph of f of x to f of x minus 2, the minus 2 makes you think that you have to go to the left. But the rule is for that it shifts, that f of x minus h shifts h units. And if h happens to be positive, well, f of x minus 2, h would be 2, right? H would be positive and shift to the right. So if you're subtracting from x, you shift in the direction opposite to one you think you would. We'll talk a little bit about why that is. But okay, so there's that. And if H is negative. This would be f of x minus h for h negative. I didn't get my rectangle about the same size, but that's impossible. In my world. So it's this or this. Depending on the sign of h. So, for example, f of x minus 7 would shift 7 units in the positive horizontal direction. Whereas f of x plus 7 would shift 7 units in the negative horizontal direction. Okay. Function that we got, the composite function. Another example. H of x is 1 over x minus 5. Let me make it a little more complete. Just repeat what we got. F of x equals 1 over x. G of x equals x minus 5. H of x equals S circle G of x we found to be 1 over x minus 5. Okay. Well, H of x is f of x minus 5. It's another way of saying f of g of x. If you replace x by the expression for g of x, the x minus 5, then you see h of x is f of x minus 5, right? Okay. So you graph of f of x. As we've learned to construct it, and if you haven't learned to construct it, you at least learn to do it by substitution. Graph. No red dot shouldn't have been there. There's a red smudge. Red smudge is not a red dot. This is a red dot. Okay. Ignore the red smudge. It's a very distant faint galaxy. Red shifted because of its extreme velocity with respect to our observation. Okay. Yeah, you don't have to know about that, but it's kind of interesting. Okay. So right here is our graph of f of x, which is very familiar to my pre-calculus students and should be very familiar to any pre-calculus student who's seen the toolkit functions. Of course, it's 1 over x, basic 1 over x function. And just a horizontal stream, here's where x equals -2, here's where x equals 2. And of course, you got y equals -2 down here and y equals 2 here. So I might as well label those. Okay, so that kind of defines the window for this particular graph. This has to be shifted 5 units in the positive direction because it's x minus 5. That's an x minus 8, or h is 5. It shifts at h units like this. Okay. Where's 5? Well, if that's 4, then 4 would be here and 5 would be about, oh, let's see. No, another red smudge. These galaxies keep getting in the way. Okay. There's your red dot. And of course, your x-axis. And then we draw this picture. We put a dotted line here. That's the x equals 5 line. Right there's our shifted graph. Okay. Now it should be obvious that we can combine 2 shifts. We can shift right or left, and we can shift up or down. So let's try this. What about y equals authorities k green power of x, just pick a letter that doesn't stand for anything else important here. Power of x equals 1 over x minus 5 plus actually this one minus 3. So if our window is here, and again, here's x equals -2, here's x equals 2, here's y equals -2. And you know what you see what I did here? I wrote the y equals -2 above the y equals 2. Okay. I made a mistake in 1971. It's been 53 years and I just made another one. How pathetic. Okay, that's 2. Third mistake, I don't know what's going to happen. Universe is going to end or something. Yeah. Glorified sense of my importance. Okay, y equals 2. And right there's my window. Now, go ahead and sketch that, and then go ahead and put a red dot in the middle because that's an important point. That's going to stand for the origin. We've got a y-axis here and an x-axis here. And show me what you think happens step by step in 2 steps to this graph. Ponder for a minute or two. I'm not going to make you think too hard. Yeah, it might cause you to make your first mistake. Okay, I think I was on screen when I corrected my error here where I had a -2 up there. Nonsense. But here's the graph we constructed. Okay, we want to construct the graph of y equals r of x is 1 over x minus 5 minus 3. Now, up here, what graph did we construct? We constructed the graph of h of x equals 1 over x minus 5. We did that by moving this graph over 5 units. Okay, so we know what the graph of f of x minus 5 looks like, or 1 over x minus 5, because that is f of x minus 5. So you could go ahead and draw this graph representing 1 over x minus 5, but then what does the minus 3 do to that graph? Okay, so what I asked everybody to do was sketch the 2 rectangles that we would get. Now, the first rectangle would be this one, because we're doing the shift, horizontal shift. Okay, x has been replaced by x minus 5, and every time that happens, you got a horizontal shift. So that's going to put you over here, actually. Okay, and then you got to go -3. Well, that means you're subtracting 3 from whatever the y values would be for this, right? Your y value becomes 3 less. That shifts the graph down 3 units, which is going to put it, I'll draw it in a different color so don't confuse the 2 graphs. I'm just going to put it lower side. Okay. Make sense? Now, actually, if we go down 3 units, it's going to kind of go right there. Okay, so I think you see that. Everybody at least move the red dot to the right and then down. Okay, now to move it to scale, remember this is 4 units wide. So we're going to move this 5 units. Well, there's 4 units and there's 1 more. And I did do it perfectly. I moved it maybe closer to 6 units on the scale that I've already defined. But if you're careful with the scale and understand what's going on, it's going to go here. And your graph is then going to be like so. And then it's going to go down here. And this is going to be the final graph. So this rectangle shows you y equals 1 over x minus 5. And this graph shows you y equals 1 over x minus 5 minus 3. Okay. Now, whatever open math shows you, you can still visualize the window, the rectangle moving around in the plane, right? And then if you want to extend the graph beyond the window, well, that's easy to do. You just put a y-axis here. This is asymptotic here, that's asymptotic there. And you could use what you know. But I'm happy just to see things in a window. And the window can be as big or small as necessary. Okay. Now, here's one more transformation that we're looking at. And there is another one that I think open math is going to talk about. It's a horizontal compression method. Yeah, you want to see that. It doesn't become important until we study exponential functions. Sore thumb. So it slipped out of the sore thumb because I didn't want to grip it any longer. It's okay. And then my focus was on that one, and I relaxed my grip on that one. Okay, that's the analytical explanation of what I did. And the other explanation is, boy, that was clumsy. Okay, there we are. It's a good thing these aren't slate anymore, because a slate blackboard had to be a little thicker and they weigh about 80 pounds. Okay. And I use those back when my thumbs are much bigger. Sorry. Okay, we have a question here, so let's get serious. Okay, now somehow I don't think I was recording. But we started with a graph of f of x. Then we said we're going to do 2f of x. Well, here's our original rectangle. If we double all our y coordinates, which is what this does, a rectangle goes up to here. It still stays on the x-axis because we're distance 0 from the x-axis here. And if we double that, we're still distance 0. The graph is looking like this. We do negative 2f of x. It's like, okay, we stretch it this way. We get the stretch graph, and then we flip it so that all positive values become negative. And the graph now looks like this. It's an upside down version of this. So here's our rule. Y equals a times f of x minus h plus k. Vertically stretches f of x by a factor magnitude of a. If we're going to do negative 2f of x, the magnitude or absolute value of negative 2 is 2. So we did that. We vertically stretched this by a factor of 2. And then if a is less than 0, which it would be for this function, we flip that graph over. And then we can do our horizontal shift of h units and our vertical shift of k units and put this stretch graph any place we need it. Okay,